Good day, everyone. In this video, we are going to take a look at applications of integral calculus to kinematics. You know that if the acceleration of a particle, if the acceleration of a particle is given as a function of time, then the velocity function of the particle is obtained by integrating the acceleration function. That is, if you are given the acceleration function as a function of time, then to get the velocity function, you have to integrate the acceleration function in order to get the velocity function. Likewise, if the velocity function is given, to get the displacement function, you have to integrate the velocity function. If the velocity function is given, then the displacement function is obtained by integrating the velocity function. For this, let us take a look at some work examples to illustrate this. Here we have example 1. The question says that a particle is projected in a straight line from point O with a speed of 6 meters per second. At time t in seconds later, its acceleration is given as 1 plus 2 in meter per second square. For the time, when the time is 4 seconds, we have to calculate for the particle its velocity and its displacement from O. Now let us take a look at the solution to this. We know that acceleration is obtained when you differentiate velocity with respect to time, and that acceleration is given to us as 1 plus 2t. Then from here we have dv is equal to 1 plus 2t dt. Then you integrate both sides. We integrate dv is equal to, we integrate 1 plus 2t with respect to t. When you integrate this will give us velocity. When you integrate 1, it will give us t. When you integrate 2t, it will give us t squared. Then plus c1, where c1 is the first constant of integration that will be determined from the initial condition given to us. But we were told that when the time t is equal to 0, the velocity is 6 meters per second. Then when we substitute this, the velocity is 6, then the time is 0 plus 0 squared plus c1. From there we get our c1 to be equal to 6. Then the original function v is equal to t squared plus t plus our c1, which is equal to 6. This is the original velocity function. So when the time is equal to 4 seconds, we have to calculate the velocity. Then the velocity will be equal to 4 squared plus 4 plus 16. Then the velocity is equal to, this is 16 plus 4 plus 6. And this gives 26 meter per second. Then we have to calculate the distance when the time is 4 seconds. We know that to get the distance function, we need to integrate the velocity function. The velocity function is given as v is equal to t squared plus t plus 6. So we know that velocity is equal to the s dt, which is equal to t squared plus t plus 6. So when we cross multiply, we have the s is equal to t squared plus t plus 6 multiply the t. We integrate both sides. We integrate the s is equal to integral of t squared plus t plus 6 dt. Then when we integrate both sides, when we integrate s, the s is going to give us s. When we integrate this one, this will give us t3 divides 3 plus, when we integrate this one, it will give us t2 divides 2 plus this one will be, when we integrate 6, it will give us 60, then plus c2, where our c2 is the second constant of integration. Second constant of integration. We can also get c2 from the initial condition given to us. We have our s is equal to t cube divides by 3 plus t squared divides by 2 plus 6t plus c2. So from the initial boundary condition given to us, at time t is equal to 0, of course, it is expected that the distance is also 0. So we have 0 is equal to 0 cube over 3 plus 0 square over 2 plus 6 into 0 plus c2. Then from here, our c2 is equal to 0. Therefore, the displacement function s is equal to t cube over 3 plus t square over 2 plus 6t plus 60. Now, we have to find the displacement when the time is 4 seconds. That is, the displacement when the time is equal to 4 seconds, it will be equal to 4 cube over 3 plus 4 square over 2 plus 6 into 4. And then from here, 4 cube is 64 divides 3 plus 16 divides 2 plus 6 times 4 gives 24. So when you combine this together, the distance is given as 160 divides 3 meter. Okay, let us take a look at number 2. The question says that a particle moves in a straight line from O with initial velocity 2 meters per second. Its acceleration in time t seconds is given by 2t minus 3 in meter per second square. We have to calculate A, its velocity after 2 seconds, B, its distance from O when it is momentarily at rest. Now let us quickly look at the solution to this. Here we know that the acceleration A is equal to dv dt, which is given as 2t minus 3. Here when we cross multiply, we have dv is equal to 2t minus 3 multiply dt. Then we integrate both sides of the equation. We have the integral of dv is equal to the integral of 2t minus 3 dt. Now when we integrate dv, it's going to give us the velocity. When we integrate this one, it's going to give us t squared minus 3t plus c1, where our c1 is the first constant of integration that we can obtain from the initial condition given to us in the equation. We were told that when the time is equal to 0, the velocity is equal to 2 meters per second. When we substitute it into this equation, we have 2 is equal to 0 squared minus 3 into 0 plus c1. Therefore, c1 is going to be equal to 2. Then the original velocity function will be v is equal to t squared minus 3t plus our c1, which is equal to 2. Then we have to calculate the velocity when the time is 3 seconds. So to find the velocity when the time is equal to 3 seconds, then we substitute the value of t to be 3 here. We have 3 squared minus 3 into 3 plus 2. So when we evaluate this one, we are going to have 2 meters per second. Then that is the first question. Then the second question, the B part of it, we have to calculate its distance from O when it is momentarily at rest. Now, you know that when the motion is momentarily at rest, what happens is the velocity is equal to 0. For that, we carry this velocity function v, which is equal to t squared minus 3t plus 2. We equate it to 0. That is, t squared minus 3t plus 2 is equal to 0. Then we solve this quadratic equation without wasting much of our time. When we solve it, our t will be equal to 1 or 2, meaning that the motion is momentarily at rest at two different times, that is at 1 second and at 2 seconds. Now, let us get the distance function from the velocity function. We know that velocity is equal to ds dt, and that velocity is given as t squared minus 3t plus 2. Now, when we cross multiply, we'll have the s is equal to t squared minus 3t plus 2 multiply the t. Then we are going to integrate both sides of the equation. We are going to have the integral of the s is equal to integral of t squared minus 3t plus 2 with respect to time. When we integrate this, we have s. When we integrate this one, this will be t cubed over 3 minus 3 over 2 t squared plus 2t plus our c2, where our c2 is the second constant of integration. Now we can obtain the value of c2 from our initial condition. We know that when the time is 0, automatically the distance is also 0. Then when we substitute the value, we have 0 is equal to 0 cubed over 3 minus 3 over 2 into 0 squared plus 2 into 0 plus c2. When we evaluate this, our c2 will also be equal to 0. Then the original function for the distance will be s is equal to t cubed over 3 minus 3 over 2 t squared plus 2t. Now, to find the distance when the particle is momentarily at rest, we are going to find the distance at two different points. So the distance when the time is 1 second, then we substitute t to be 1 second. This will be 1 cubed over 3 minus 3 over 2 into 1 square plus 2 into 1. Then this will be 1 over 3 minus 3 over 2 plus 2. Then from here, when we evaluate this one, we'll have this. The LCM here is 6, and this will be 2, this will be 9, this will be plus 12. Then this will give us 14 minus 9 over 6, and this gives 5 over 6 meter. So at 1 second, when the particle is momentarily at rest, the distance covered from O is 5 over 6 meter. Then let us find the distance at the second time. When the time is 2 seconds, then this will be 2 cubed over 3 minus 3 over 2 into 2 square plus 2 into 2. And this will be 8 over 3 minus 6 plus 4. And this will be 8 over 3 minus 2. And the LCM here is 3. This will be 8 minus 6. And this gives 2 over 3 meter.